Hello everyone, welcome to my channel. William Talk Physic Easy. Hello all, welcome to my channel. First of all, I want to say welcome to all the juniors to Matriculation College for all states in Malaysia. Today I'm going to introduce some briefing on physics subject in our matriculation syllabus. So, in my point of view, I think that matriculation syllabus consider on some brief theory, such as some consequence or effect when changing some data or something relate to the formula relationship in the exam questions. And the exam questions are focused more on calculations in both semester. So I think that physics is not a problem, just like we need to do more exercise, asking our teachers, our lecturers frequently, and pay attention is the most important. Showing our respect to them. Yeah. So how about the mark allocations? For the previous semester 2022/2023, our mark allocations have both, which is PB, and our final exam, which is PSPN. What is PB? PB is a continuous assessment, which includes our attendance and also some tests, which is called as UPS. It's like a test after our lecturer teach for few chapters. And for my semester is online lah. So for UPS we have 3 and was scheduled. We must have attend for both 3 UPS. Also we can study with our friends and do it with our friends in cafe or in our room, or also in library as well. So this 60 mark is like a starting point. Before the final exam, try our best to get full for the continuous assessments, as all students in Matriculation College will have the same starting point. If you get less than 60 marks, then your starting point is different with others and you must push more on your final exam. So final exam, the full paper is 80 marks, but we only calculate into 40 marks for our final result. And also the UPS for semester 1 is more on theory and has some calculation as well. But for the semester 2, UPS is focused on theory only. I think it's quite easy and simple to understand, right? In conclusions, I think that physics is not a problems, not a big problems what we're facing. If we do all the exercise given by our lecturers, the past year questions, and before our exam, final exam, we push ourselves, we do all the state trial papers that will be sent out in the Telegram group or WhatsApp group. I think we definitely can get a A. So let me introduce for SP015 physics subject in matriculation syllabus for semester 1. Topic 1 is physical quantity and measurements. So for measurements like the vernier calipers, the meter rules, the uncertainty, I think that you all can get access in others YouTube videos that have some simply explanations on how we going to calculate using the measurements instrument like flashing back, or since we have learned it in our secondary school as well. So what is physical quantities? Physical quantity is a quantity that can be measurables, can be calculated. So for physical quantities, they have two types, which is base quantity and derived quantity. So what is base quantity? Base quantity is a quantity which cannot be derived from any physical quantity. So he also known as basic quantity. The basic quantity that cannot be derived. Then the second one is derived quantity, which means that quantity that can be expressed in terms of basic quantity through multiplications, divisions, or both. So next, for 1.1, dimensions of physical quantities. So this is a new subtopic that we haven't learned in our secondary school. So what is dimension? Dimension is a technique or methods which physical quantity can be expressed in terms of combination of basic quantity. In secondary school, which is the topic 1 in Form 4, we only learns on how we going to derive a derived quantity into a basic quantity. So this one is express the physical quantity in terms of combination of basic quantity. So there have 5 base quantity that we have learned in secondary school. You all can take as a reference. So how we going to write the symbol dimensions? For symbol dimensions, we use the square brackets. So inside the square brackets, we either write the symbol of the physical quantity or the name of physical quantity. For example, mass. We either write the small letter of the M or write the mass, the name of the physical quantity, which is the mass. And after the dimensions, we will get capital letter of the symbol. So the common use is dimension of mass, dimension of length, and dimension of time. And after the dimensions, dimension of M will get capital letter of M. Then for dimension of length, we will get capital letter of L. Then for dimension of time, we will get capital letter of T. And for less common example, dimension of currents, we will get capital letter of I. Then dimension of temperature, we will get theta. Then dimension of number of substance, what we learned in chemistry, we'll get capital letter of N. And the last one is dimension of luminous intensity, a unit to measure the intensity of light, and we'll get capital letter of J. So don't wasting time, let us see some example. Example 1, force. The equation of force is equal to mass times accelerations, F equal to ma. So dimension of mass, we definitely get capital letter of M. Then for accelerations, we know that accelerations formula is change in velocity, which is final velocity minus initial velocity over the time. So velocity is displacements over time. So for alternative pathway to this subtopic, we can directly figure out the dimensions using the unit givens. So for accelerations example, unit of acceleration is ms per square. So m is meter, the length, and s is the time in seconds for SI unit. Dimension of length we'll get L, capital letter of L, then dimension of time, which is in seconds, we'll get time, and the power -2 must include inside also. So finally, we'll get dimension of force is equal to capital letter M times capital letter L times capital letter T with power -2. Then example 2, density. Formula of density is mass per volumes. What we learned in secondary school by Darling, Vivians, or some else, how we memorize it. So volume is equal to length times width is height. So both three, the unit is in length, which is the SI unit is in meter. So dimension of mass over dimension of length times dimension of length times dimension of length. So we will get the final answer of dimension density is equal to capital letter M times capital letter L with power -3. Next, example 3. Given that the formula F equal to G, M for object 1, then time with M, which is the mass for object 2, over the R square. The R is the radius. This is what we learned, the Newton's law of gravitation, which is the chapter 3 in our form 4 syllabus. Then, given that this formula, the question asks us to find out the dimension and SI unit of the constant G. G is a constant. So, firstly, we interpret G by using this formula, and we will get G is equal to F times R square over M1 times M2. So we can do it separately. For F, just now what we learned, F is equal to MA, dimension of M's time dimension of A, we will get capital letter M's time capital letter L time capital letter T with power -2. Then for R square, dimension of R square, since we know that R is radius between the two objects, so dimension of R square and the SI unit will in meter, which is length, and we will get dimension of R square is capital letter L with power of 2. Then M1 times M2, dimension of M1 times M2, both are mass. So after dimension, we will get capital letter M with power of 2. So substitute into the formula and cancel off to simplify the dimensions. We will get the final answer is capital letter M with -1 power times with capital letter L with factor of 3, then capital letter with power of -2. And the SI unit, how we convert dimension into SI unit? M is mass, so SI unit is kg in kg. Then for length, SI unit of length is meter, and subsequently for time, SI unit is in seconds. So don't mess it up. Even though when I'm in the semester 1, I always confusing, doing some minor mistake for the dimension of the length. Like I use the alternative pathway, I change the M into the capital letter M instead of capital letter L. So don't do this minor mistake. Dimensions of length always is capital letter L, not capital letter M. Although the SI unit for length is meter. Then there are 3 questions that I'm going to ask you all. with provided answer. Question 1 is speed, and the question 2 is work done. I give you all a hint. For work done, equations is equal to force times with displacements. W equal to F times S. Then the third question, for power, the equation of power is equal to work done over times. So find out the dimensions for following questions and also their SI units. Next. For this subtopic, typical question always asks us to find out the dimensions and also the SI unit of the equations. And the next famous equation is determine the expressions are dimensionally correct or not. So, for the dimensions analysis, there are three simple theory. If dimension of left hand side of the equation is equal to dimension of the right hand side equations, proven that the equation is homogeneous, or we call as dimensionally correct. In other words, if dimension of right hand side is not same as the dimension as the right hand side, the equation is dimensionally incorrect. Next, for dimensions cannot be added or subtracted, only can be times or divided. I give you all an example like just now. For equation of acceleration is final velocity minus with the initial velocity over the time. So for dimension of final velocity and dimension of initial velocity over the time, we will get for speed dimension is m per s. So we will get length times with 10 power negative 1 times L times with capital letter T with factor of negative 1s over time. So since what we talked just now, dimension cannot be added and subtracted. So LT with factor of negative 1 minus LT with negative 1s, the final, we also will get LT negative 1s over T. And the final answer is L capital letter of T with a factor of negative 2 for accelerations. Just like final velocity subtracted with the initial velocity, we will get the change in velocity, which also is unit is in m per s. And the m per s dimension we will get L T with the factor of negative 1s. Thirdly, for dimensional constant always in 1, there are 4 cases for dimensionless constants, which is dimensions of numbers. For example, dimension of 2, we get answer 1s. Dimension of the constant value, like dimensions of the refractive index for a specific materials, is constant value. So we'll get 1 also. Then dimension of angle, like 60 degree or shift tangents 5 point somethings, we'll get 1 also. And the last case is ratio of two quantity that having the same dimensions, like dimensions A over dimensions B, we'll get 1 also. So here are 3 basic theory for this subtopic. Let us see the following sample questions. Given that the equation S equal to ut plus 0.5 times with at squared, where the S is displacement, u is the initial velocity, the time is in t, and the a is accelerations. For such questions, ask us to prove the expressions are dimensionally correct or not. We must divide it into left hand side and right hand side. Left hand side is S, the right hand side is this. So dimension of left hand side, dimensional of S, the displacement, we will get capital letter of L, since displacements is considered as the length. Then for the right hand side, we can do separately. Dimensions of U times with dimension of T, we will get L. Then dimension of 0.5, 1/2 times dimension of A times with dimension of T squared. Dimensions of 1/2 is a number. Since it's a number, it's a dimensionless constant, and we'll get 1. And dimension of accelerations, we'll get LT with the factor of -2. Then T squared will get capital letter of T power of 2. Then we simplify it, we'll get L. Since dimensions of left hand side and the right hand side is same, among these three, the dimension is L. So thus the equation is dimensionally correct. Next, example 5. Equation P equal to rho times G times H, where the P is the pressure, the rho is density, the G is gravitational accelerations, and the H is height. Same. Left hand side dimension of P. P is equal to F over A. Pressure is equal to force over the areas. So for force is kg ms power -2. So dimension of force will get m for mass, L for the length, which is meter. Then the T is time, mLT, and the T is with a factor of -2. And area is capital letter L square. And we get dimension of pressure is M times with capital letter L with power of -1 times with the capital letter of T with a factor of -2. Then for the right hand side, density, just now we have done the sample. Density is equal to mass over volume. So we will get the capital letter of M over capital letter of L with a factor of 3 times with the G gravitational accelerations. So it's also accelerations. So capital letter of L over capital letter T with power of 2, and the height is capital letter of L, and we get the dimension for the right hand side for PGH is capital letter of N times with capital letter L with power of -1, then time with the capital letter of T with a factor of -2. Since dimension of the left hand side is same as the dimension of the right hand side, thus the equation is dimensionally correct. After we prove that the dimension is same, we must write the sentence to conclude our answer. This symbol is since, means like since in maths. So I have 2 questions to ask you all. This first one, given that the equation v equal to u minus 2gs, where v is the final velocity and the g is the acceleration due to gravity, 9.81 ms power negative 2. Then the second question is a triangle that has sides A, B, and C. Then a circle with radius of RCM can be drawn into the triangle, given that the R is equal to square roots S minus A times with S minus B, then times with S minus C over the S. S is the displacements, where the S equal to A plus B plus C over 2. Do you all feel familiar for these two equations? Actually, this is what we learned in our secondary school for math subjects, which is Heron's formulas to find the area of a triangle in terms of the length of its sides. So the question asks us to determine the homogeneity of expressions of R. So try to do it. Next, 1.2, scalar and vectors. Both physical quantities we have learned in secondary school. For scalar quantities, it means by a type of physical quantity that only has magnitude. We only consider magnitude. For example, distance, length, area, speed, density. Then vectors, a type of physical quantity that has both magnitude and direction. So we going to consider magnitude and directions. For example of the vector quantities are displacement, velocity, accelerations. So what is the difference? I give you a scenario, like for scalar quantity, the car has moved 5 kilometers away. Then for vector, the car has moved 5 kilometers to the north, showing us the direction of the movement of the car. So we can see the difference. So for physics, the assumptions, the direction to the left always in positive, and consequently to the right is in negative. So we must write out the positive and negative sign. Then for the upwards direction is positive, and the downward direction is negative. And N is north, E is east, S is south, W is west. So positive or negative sign is very important when we resolve the vector quantity into the horizontal component, which is also known as the x components, or the vertical components, which also known as the y components. Next, now we're going to talk about some learning tips to resolve the vector into the x components and also the y components. So for this subtopic, what I learned is I used to analyze if the given vector with the angles that closer to the either components, like for this the 50 angle is closer to the x components. So for the resolve of this s value, when we resolve the s, we'll get the s for x components, which we can write in sx, and the vertical components, after resolve the x, we'll get the sy. So for this x, since its direction is to the left, so it's positive, and this xy is to the upwards, so positive sign also. Then the angle that closer to the components, the either components, I will use the value, the s cos with the angle, 50 cos 50 angles. So this actually is like a mathematics theory. How are we going to find sx? So for xx, the simpler way to use is by using the cos. Since cos theta is adjacent over the hypotenuse, so cos 50, the angles, is equal to the adjacent is xx over the hypotenuse 50. So xx is also equal to 50 times with cos 50 angles. Then for the sy, how are we going to find sy? So we can use simpler way, which is sine angle it. Sine theta is equal to opposite over hypotenuse. So sine 50 equal to sy over 50. So sy is equal to 50 times with sine 50 angles. I'm utterly sure that you all have learned in your secondary school. So for the horizontal components, the sx will get 32.14 meter, and for the vertical component, the sy will get 38.3 meters. Next example. Given that the v value is 40 meter per second, so this is our speed or velocity. Because we have direction, so it's velocity with angle 60. So the alternative pathway we can analyze, like in mathematics, this one is called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So for quadrant 1, both are positive. For quadrant 2, y is positive and the x is negative. Then for the quadrant 3, x axis and the y axis in negative for both. And for quadrant 4, the x-axis is in positive and the y-axis in negative. So for this v vector is lie on the quadrant 3. So after we resolve into the x components and negative components, we will get both components is negative. So vx, the vx, since the vx is here and the angle given is far from the x component, so we use sine instead of cos, just like what we talked just now using the maths. But how I going to do it in a speedy way? I use this. If the angle given is closer to the components, we use cos, and the angle given is far from the components we need to calculate, we use sine. If here is 40, then the Vx is equal to negative 40 cos 30. But given that 60, we don't mess it up. We just use one angle. So Vx is equal to negative 40 sine 60, since the angle given is far away from its components. Then for the Vy, we get negative 40 cos 60, since the angle given is closer to the vertical components. And the final answer is this. Next. Example 3. For such questions that given that more than one force acted to a object O, particle O, we must use table form so that we can do it in a smoothly way and prevent some careless mistakes when we substitute into the equations. Firstly, we analyze the force diagram. The first force is acted with an angle. So if we draw for the object O, we can use the angle. Since the angle is lie in the quadrant 3, we can draw it in the quadrant 3. And how we get the 60? Since for max, the angle for here and also for here is same, so here also 60. So that's why we will get 60 at here. So for force 2, we no need to resolve it since the force 2 exactly is horizontal components, which is positive 30, since its direction is to the left. The only force we need to resolve into the x component and y components is force 1. So substituting all into the table so that we can do it in a smooth way. The x component for the F1 is negative 30 cos 60. We'll get negative 10 newtons, and the vertical components of F1 is 30 sin 60, which is 17.32 newtons. Then for F2, the Fx, the horizontal component, is positive 30 newtons, and for the vertical components is 0. So we plus it. Negative 10 plus 30, we get 20. For the total of the vertical components for the resultant force is 17.32 newtons. That's why just now I thought the positive and negative sign is very important when we plus minus for the force that have more than one types. Then we will get sum of the force for horizontal components and also the sum of the force for vertical components. So for force resultants, the equation is square roots sum of fx square plus sum of fy square. This actually is the max theory for the triangle Pythagoras methods. Since the fx and fy is positive, we will know it is lie on the quadrant 1. So this is what we need to find, the force resultant. So we get the Fr, the resultant force is 26.46 newtons. And how are we going to find the angles? For such questions, we need to find the resultant force with its angles. So the angle we use tangents simply because we already find out the opposite and also the adjacent. So tangent theta is equal to opposite over adjacent, which is also equal to sum of fy over sum of fx. And we'll get the theta is in angle 40.89 degree above positive axis. Since the angle is in quadrant 1, so in quadrant 1 means in the above of the positive x-axis. If in quadrant 4, then only is below positive x-axis. Then for quadrant 2, the angle is lie on above of the negative x-axis. Then for the quadrant 3 is below of the negative x-axis. Alright. Let us do 3 simple questions that have been came out in UPS and also the final exam. So the first question is given 3. Now given 3 type of the force. The force one is 1200 newtons with angle 30. Then the second force is 500 newtons with angle 20, and the third force is 200 newtons with angle 60. So we're going to find the resultant force also with the angles of the resultant force using the method that I just now taught. Next, question 2. A girl pushes a box across the floor and cause it to undergo 2 displacement A and B. The displacement is A is 1.5 meter along the positive x-axis, while the displacement of B is 1.4 meter along the positive y-axis. Determine the magnitude and direction of the resultant displacement. For such subtopic questions, we may be given a scenario, so we need to analyze by ourselves. Just now, like how I draw this, analyze the force diagram. So displacement of A is 1.5 along positive x-axis, and displacement of B is 1.4 along the positive y-axis. So what we get is the displacement A is here as A, displacement A, since it's positive axis. Then the displacement B is in direction of positive y-axis. So this is our SB. So the resultant is lie on the quadrant 1 as R. So find out the resultant displacement. Next, third questions. It's given that this, but there are some specials for these questions. Let's see. Vector P and vector Q are shown in figure above. Determine the resultant vector if resultant vector is equal to resultant P minus resultant Q. So for such questions, the P and Q resolve into x components and y components, then only we use this formula, imply these formulas to find out the sum of the Rx and Ry. Then only we can find out the R and also the angles of the resultants. So it's the end of our videos. I will continue to update for the subsequently topics for semester 1 and also semester 2. Don't forget to hit the like button and share this video to your friends. Also, subscribe to my channels. Thank you everyone. I will see you in the next video. Bye.